In this video, I want to have a look at finding the general solution to trig equations, specifically looking at equations involving cosine. So what that means is that all the trig equations we've solved so far had a restricted domain. So they might be going between 0 and 2 pi or minus pi to pi. But the equations we're going to have a look at now don't have a restricted domain. So for example, if we were asked to solve the equation cos theta equals a half, there's actually infinitely many answers to this. And obviously we can't write them down one by one, so we have to come up with some way of representing those infinite solutions. So to start answering this, we're going to start the same way we normally would. We'll draw ourselves an all stations to central diagram. Now cos is positive in the first quadrant and the fourth quadrant. And because we've got cos theta equals a half, our related angle there is going to be pi on 3. Now I want to have a look at these two solutions separately. So first I want to have a look at this one here. Now we could go around this diagram infinitely many times in an anti-clockwise direction and infinitely many times in a clockwise direction. So let's start with the positive solutions. Our first solution would just be pi on 3. If we did a whole nother revolution, that would get us to 2 pi plus pi on 3. If we did another revolution, we'd get to 4 pi plus pi on 3. So that's all going in the anti-clockwise direction for our positive solutions. If we went the other way, we would end up with round all the way around revolution would be minus 2 pi, but then we've got to come back this way. So we'd have minus 2 pi plus pi on 3. If we did another revolution, we'd have minus 4 pi plus pi on 3. And we could keep going there as well. Now, if we wanted to come up with some sort of general formula for that, we could write it as theta equals 2n pi plus pi on 3. So notice that we only have the even numbers. If we kept going, we'd have 2 pi, 4 pi, 6 pi, 8 pi. So that's why we've got our 2n here. This one here that was just a pi on 3, that n would have been a 0. So this term would have been 0. For this term, our n would have been 1. For this term, our n was 2, and so on. For these ones, our n's would have been negative. So our n would have been negative 1 or negative 2 for this one here. So this is the general way that we can write the solution for this red ray there. Now, if we have a look at this ray coming down this direction instead, so for that one, we're going to have theta equals, now if we go in the positive direction first, we'd have 2 pi minus pi on 3. Do another revolution, we'd have 4 pi minus pi on 3. We could do another revolution in that same direction, we'd have 6 pi minus pi on 3, and we could keep going there. If we go in the anti-clockwise direction, we'd have minus pi on 3. We could have minus 2 pi minus pi on 3. We could have minus 4 pi minus pi on 3 if we go around again, and that would keep going on as well. So to generalize the solutions for this purple ray, we would have theta equals 2n pi minus pi on 3 instead of plus pi on 3 this time. So that n is still any integer, either positive or negative, and that will get us all of these solutions. So if we want to combine these two general solutions into one answer, we could write it as theta equals 2n pi plus or minus pi on 3 for this equation. Now if we have a look at what those solutions look like in a graph, so here we've got our graph of our cos function, and I'm going to add in this line, which is just the line y equals 0.5 or y equals a half. So these points of intersection are our solutions. So what our formula said, our general solution just said, was that we were going to have 2n pi plus or minus pi on 3. So if our n was 0, we'd have 0 plus or minus pi on 3. So you can see that 0 is here. If we go plus pi on 3, that's one solution. Minus pi on 3 is a second solution. If our n was 1, we'd have 2 pi plus or minus pi on 3. So you've got 2 pi plus pi on 3 and 2 pi minus pi on 3. Again, if n was 2, we'd have 4 pi plus or minus pi on 3. So that's plus pi on 3 and minus pi on 3. If our n was negative 1, we'd have minus 2 pi plus or minus pi on 3. So you can see all of our solutions represented there. So to summarize that, for cosine equations, the general solution can be written as theta equals 2n pi plus or minus alpha, where alpha is our first positive solution, and that's in radians. If we wanted to write it in degrees instead, we could write it as 360 times n plus or minus alpha degrees instead. Let's have a look at an example. So our example asks us to find the general solution to the equation 2 cos 3x plus 30 degrees plus root 3 equals 0. So the first thing we're going to do is to rearrange this. So we can have 2 cos 3x plus 30 degrees equals minus square root of 3. Then we could divide by 2, so we'd have cos of 3x plus 30 degrees equals minus root 3 over 2. Now to solve this, we're going to draw up our all stations to central diagram. We know that cos is negative, so that's going to be in our second and third quadrants. And from our special triangles, our exact values, our related angle is going to be 30 degrees. So that means that our first solution is this angle here, which would be 150 degrees. So that means that if we had cos theta equals minus root 3 on 2, our solution would be theta equals 360 degrees times n plus or minus 150 degrees. Now we didn't have theta though, we had 3x plus 30. So that means we've got 3x plus 30 degrees equals 360 degrees times n plus or minus 150 degrees. Now to actually go through and solve this for x, I'm going to split it into its two separate cases. And I'm going to bring it up here just so I have enough room. So that means I'm going to have 3x plus 30 degrees equals 360 degrees times n plus 150 degrees, or 360 degrees times n minus 150 degrees. So now that I've got those, I can subtract 30. So I'm going to have 3x equals 360 degrees n plus 120 degrees, or 360 degrees n minus 180 degrees. Now I'm going to divide everything by 3. So I'm going to have x equals 120 degrees n plus 40 degrees, or 120 degrees n minus 60 degrees. So those are our two solutions, two general solutions to this equation here.